So I thought this would be a good chance for us to kind of go back and review the information that you'll need to know and kind of put together for the atomic structure unit that we're working on now. So this is page 1 and 2 of that packet that you hopefully picked up, and we've got the different people listed here on the left side, front and back. But what I really want to spend the most time on is these models of the atom, the different people have introduced and how it's changed over time. So Democritus, Aristotle, and Dalton, we sort of talked about them, not sort of, we did talk about them in the last unit. Of course, Dalton's ideas incorporated several other people's ideas, specifically law of conservation of mass and the law of definite proportions from other people. Hopefully you've learned about Thompson in this one, and so we'll start with these two guys. So when you think about what Dalton said and what he knew about the atom, it was really pretty basic. He didn't know anything about the internal structure of the atom. And so according to John Dalton, atoms were indivisible particles. And so sometimes his model is called the billiard ball model. It's basically just a sphere. Mine's just going to look like a flat circle. Maybe we've got a little shading there. But if you can think about like the cue ball on a pool table, that's sort of what Dalton envisioned the atom to be. Just sort of featureless, a solid sphere, of course, very, very, very tiny, but, you know, nothing inside, just a ball of stuff. Now, as you know, Thompson figured out that the atom really was more than that. So I want you to think about what changes as we go through time. Thompson kept this idea of the atom, but what he added to that was the idea that there are these little negatively charged particles that are embedded throughout the atom. And of course, we now know that those are called electrons. That wasn't Thompson's word for it, but that's essentially what we're talking about. They have negative charge. Now, you may or may not have picked up on this little piece of information, but in addition to having negative charge, Thompson realized that the atom is neutral. It doesn't have charge. And so if it's neutral and he knows you've got these negative electrons, then Thompson figured out, well, there must be some positive stuff. So that's what I'm putting in here, positive stuff. And he said that the atom really was like, he said a plum pudding. So you hear that frequently. Plum pudding is not really like we think of pudding. It's more like a cake. And it doesn't have plums. It has raisins. I don't know why they call it that. But those electrons are just embedded within this cake-like material. We might think of it more like a blueberry muffin. You hear that a lot because we're more familiar with blueberry muffins than plum pudding. So if we think about like the blueberry muffin, then the electrons are like the blueberries, and the positive stuff here is just like the cake, the muffin part that those blueberries are embedded in. And so that was Thompson's idea. Notice, again, we didn't get rid of what Dalton said. We still have atoms, but we're just adding to the model as we learn more about it. That's the way science works. So next on our list is Rutherford. We still believe in atoms. We have evidence for atoms. The electrons are still understood to be just kind of scattered around. So what Rutherford added to our story is instead of having this positive stuff everywhere, Rutherford figured out that all of the positive charge was concentrated in the nucleus. And so this was with the gold foil experiment, if you remember what happened there. All of those alpha particles, or almost all of them, passed through because he figured out the atom is mostly empty space. But the few alpha particles that were close to the nucleus, or came close to the nucleus, either bounced back or just were kind of deflected off to the side. And so because of the ratio of the number of the number of alpha particles that were deflected, he figured out that the nucleus really is not very big. The positive part of the atom is not very big. These are still the electrons. And so the nucleus is where the positive charge is. And of course we know it's in protons, and we also know that the nucleus contains neutrons. That's a little bit extra to the story. Now, the next, again, haven't thrown anything out, we're just adding to. So the next person that we need to look at, who gets credit for what we now understand about the atom, is Niels Bohr. And so what Bohr said is, Rutherford's right. There's a nucleus there. Dalton is right. I guess we need to start there. We do have atoms. But what he figured out is, within these atoms, the electrons aren't just randomly scattered out. Bohr said that the electrons orbit the nucleus in very defined pathways. And so we have Bohr models. And each level can hold a different number of electrons. So let's say this one looks like this. So sometimes this is called a planetary model. Because Bohr said that the electrons orbit the nucleus are like the planets around the sun. We know more about that now than we did then. Oh, let me back up here. This is called the nuclear model. But here again, this is how science works. We just keep adding new knowledge in as it fits into the model that we already have. New evidence doesn't get rid of the old model, it just modifies it and makes it better and better and better. We get more and more detailed and more specific as we look at the different models of the atom. So really this is where we are at this point in what you've studied so far. There is one more model that is the current model of the atom. So all of these, have their limitations. The current model of the atom is called the quantum mechanical model. And so if you watched The Big Bang Theory, or if you watched, what was it, Johnny Neutron back in the day, that may be before your time, you've seen that little diagram of the atom. You've got a nucleus, and then the energy levels actually aren't just two-dimensional, they're actually three-dimensional. And so they sort of try to illustrate that by making these different, bubbles, different orbitals is what they are, that go different ways around the atom. And so the electrons then are going to be scattered around on these orbitals. So again, these are the electrons. This is your nucleus. And these are orbitals. It's more of a three-dimensional idea than this one. I guess I should label this one. So I hope this is helpful as you kind of think about the big picture in terms of what we know about the atom. A lot of times when we have this discussion in class, students will ask, well, is it possible that we're going to change this model? And absolutely, it's possible that we're going to change that quantum mechanical model as we learn more about the atom. Now, again, I don't think that we're going to get rid of protons, neutrons, electrons. We have way too much evidence that those things actually exist. We have a whole lot of evidence that energy levels and orbitals exist. So I don't think it's a matter of throwing things out. It's just a matter of adding to our current models. So again, that's just a summary of the models of the atom, how they've changed and developed through time. Lift that up here so you can see the whole thing. I hope that's helpful to you, again, as you try to put together everything from this unit. but this is one of my favorite examples of how science works. We didn't start here. It took hundreds of years, literally, to get from, what we know here to where we are now, to get to this point, and then beyond that. So that's it for this little video. I hope it's helpful, and I will talk to you guys soon.